variable, dependent variable, can be explained by the other variable, independent. How the change in cholesterol can be explained by, let's say, weight or something else. That is what was our initial focus. If we do it with one variable, we called it as simple regression. Multiple variables, we called it as a multiple regression. And the parameters are telling us the relationship between the variables. Now, how do I see the relationship between the variables? One way is I can do a plotting. Even in case of correlation between two variables, before finding out correlation, we also talk about a kind of a scatter plot. It's just a diagram between the dependent and the independent variable. If I see here, I plot a scatter between, let's say, the cholesterol and, let's say, the weight. I want to see what is the relationship that is existing between the two. Only two variables at a time. So for that I can do what is called as a scatter plot. Scatter plot is something where one variable is there on the x-axis, the other one is on the y-axis. Out of those two which I am considering, I am taking one on the x, the other on the y. So I will take a scatter plot. Wherein I take one variable on the x. So probably I'll take the weight on the x-axis. Doesn't matter what I am taking where. I am taking weight on the x-axis and cholesterol on the y-axis. So this is the typical kind of a graph that got generated to me. Where is it? So this is the kind of scatter plot that got generated. Now I can draw. What does that mean? Whatever is the weight, right? I have people right from 30, 40, 20 in terms of weight. Whatever is their weight, the cholesterol levels were fluctuating only between that level, right? Now, if I try to draw, see, if there is a very strong relationship, what will come out is, as x is increasing, y also keeps increasing. If it is a strong negative relation, at least I can see that if x is increasing, y will start falling. So either it would be a fully down kind of a line or fully up kind of a line. But here if you try to draw this line, you are seeing neither too much up nor too much down. This line is what we called as a regression line. What is this line telling me? Now, see, these are all the points. When I plotted x and y, these are all the points. Whatever are the diamonds, they are all the points. Now my question is, draw one single line which joins all the points. If I am able to do that, then my prediction is extraordinary. But at least if I am not able to do that, draw a line which is the best fitting line. Best. Out of all possible lines, out of all lines possible, right? Multiple lines are possible here. Out of all lines possible, which one is the best? So many lines are possible, right? Some of them join some point, some of them may not join some point. So out of all the possible lines, which one is the best out of them? What do we mean by best? When I look at the error of the point with respect to the line, how much is the deviation of each and every point from that line? That is what we have called as error. So in what line, what is the best line where when I take the errors of all the values around it, That is the minimum most possible. So in this graph, it has identified that this line, the black line, is that best possible line. But even for the best possible line, right, even for the best possible line, we are seeing so many errors, so much of deviations. Correct? Even for the best possible, see, out of these points, that is the best possible line. Even the best possible line is showing so much of fluctuations. Right? In case where a regression is very perfect, the predictions are very perfect, what we see is the errors will be very, very minimal. Right? The errors will be very, very minimal. In that case, we'll say that I can predict this using this. So there is a scatter plot with which we are starting off, predicting the relationship between the two variables, right? Plotting the relationship between the two variables, and a regression line is nothing but the line that best joins all the points very closer to all the points, one single straight line. So even if that one single straight line, you will find that not many points are lying on that line. So many are very much away from that line. It's an indication that the explanatory power is very, very poor. It's an indication that the explanatory power is very, very poor. And that is a graphical way of looking at it. The mathematical way of doing it is nothing but your regression and the calculations of regression and all that aspect. So indicates a positive or a negative or a no relation the moment I plot a scatter. Now you see the line, it's almost flat. That line is neither too up nor too down. It's almost flat. Flat means almost no relationship between the two. Even if it is there, there is a slight positive relation. Slightly up. There is a slight positive relation, but almost flat kind of a relation. And it also talks about, sometimes if I examine it very closely, sometimes non-linear relationship patterns also can be observed. Again, for that I need to understand the graphs of non-linear. Probably if I have a graph like a curve like this, it indicates a square kind of a relation. Right? Probably just to showcase, if I take, let's say, -5, -4 kind of numbers, just showing you one example. Let's say I take the square. I take the square and try to plot a scatter plot between these two. You see the graph comes more like a parabola kind of stuff. So probably if at all I am able to see a graph like this, then it shows that there is a square relationship between the variables. Not a linear relation, but a kind of a square relation. But probably the same thing if I do it with cubes, my shape would be something different. If I do the same with cube, now you see what is the shape that comes out. So if at all in my data I observe a pattern like this, then I say that y and x are related by cube. So sometimes what happens is, by observation of the data itself, by observation of the plots, the scatter plot, if at all I see some specific shape, of course this is not in our scope also, our scope is more on a linear regression itself where we draw a line itself. But if at all we have such kind of shapes, we can say that there is a square relation or a cube relation between the variables. Right? So that is one thing which can come through the scatter plot. The most common thing that comes through the scatter plot is the relation, the positive or negative. But sometimes it may also talk about the presence of non-linear kind of relationships also, just by looking at the graph. And coming to the regression equation, we have already discussed. With one variable, it is y equal to a plus bx kind of a form. Otherwise, probably with multiple variables, I am doing the multiple part here itself. A plus bx1 plus cx2 plus dx3, something like that is what goes with multiple variables. There is an intercept which is a, and there are slope coefficients which are b, c, d kind of stuff. And whatever is the line that got in the figure, that line has an equation. Any straight line, the equation is of this form itself. For any straight line, no squares, no cubes, variables and multiplication with some coefficient for any straight line. So for that line also there is some equation, and that equation is what we are determining here. So in that we also discussed all these things, right? So the meaning of the intercept is, if all the x values, all the x1, x2, x3, all of them are zeros, what would be the value of your y? That is what we called as intercept. When the weight, when the blood pressure, everything is zero, what is the cholesterol value? That is what we called as intercept. And when it came to slope, when one unit of that particular variable, if that variable is increased by 1 unit and nothing else changed, what would be the impact on the dependent variable? That is what we called as the slope. Error value we have already discussed, actual value minus the predicted.